Before we talk about history, definitions, or anything else, I want to start right where most people's curiosity actually lives. How would someone even try to preserve a snowflake? I'm going to walk you through a gentle educational tutorial, and it's not my exact process. It's not meant to turn anyone into an overnight expert. It is simply to help you understand what is happening and why this is considered a skill. If someone is exploring snowflake preservation using cyanoacrylate, also found in superglue, the most important thing to understand first is this. Snowflakes must be captured and worked with below freezing. Once they warm, they're gone. People usually start by chilling all their tools and surfaces outdoors, glass slides, metal trays, or anything that you're planning on using. Snowflakes can be easily seen and are less likely to break apart this way. Snowflakes are collected gently, often with a fine brush. Once the snowflake is in place, everything is cold. A very small amount of cyanoacrylate can be put on top. This is the part where skill comes in. Cyanoacrylate reacts extremely quickly with water. If the conditions are right, the reaction happens before the snowflake collapses. Water molecules transition into a solid polymer form, and the crystalline lattice is supported. If conditions are wrong, the snowflake melts, distorts, or it disappears. Learning how much material to use, how fast the reaction needs to occur, how temperature and humidity affect the outcome, and how to recognize success versus distortion all take practice. This is why results vary so widely. The material itself is very accessible. The mastery comes from experience, and that is the heart of snowflake preservation. Trying this at home can be a meaningful learning experience, even when it does not work perfectly. What most people discover quickly is how sensitive snowflakes are and how narrow the window for success really is. That understanding alone deepens appreciation. Now that you have a basic idea of how snowflake preservation works in practice, everything else will make more sense. Because snowflake preservation is only partly magic. It's chemistry, timing, and care. A snowflake is not frozen rain. It forms when water vapor in the atmosphere organizes itself into a crystalline lattice. That lattice is hexagonal, always. Temperature and humidity determine how detailed that structure will become. So when you look at a snowflake, you are looking at geometry, physics, chemistry, and weather history all at once. And it is incredibly fragile. The word preserve does not mean frozen forever. It does not mean frozen still. Preserve means stable. Preserved flowers are no longer alive. Preserved butterflies are no longer alive. And preserved snowflakes are no longer frozen. The structure remains, the form changes, and that distinction truly matters. Wilson Bentley, my absolute hero, photographed snowflakes in the early 1900s. He preserved them visually. Later, scientists like Trygve Emilsson wanted physical samples. Inspired by Bentley, they started to study and in the late 1970s developed a polymer method that allowed snowflake structures to be stabilized while still frozen. That work showed that if you act quickly enough and carefully enough, a snowflake's lattice can be supported before it collapses. Modern snowflake preservation builds on that foundation. There's more than one method, and none of them are shortcuts. Polymer coating methods. These use very thin polymer solutions such as Formvar or polyvinyl-based coatings. The snowflake is captured below freezing, and the polymer coats the structure. The water transitions, and the lattice remains. These methods are common in scientific research. Cyanoacrylate-based methods. This method is widely known and widely attempted. What makes it difficult is not access to materials, but learning how to work with extremely narrow windows and conditions. It is a skill, just like many other crafts and scientists. You learn to read the weather and the snow and act accordingly. The word resin is not just for epoxy. Resin does not preserve a snowflake. Resin is used after preservation to protect and display what has already been stabilized. If epoxy resin touches a snowflake at room temperature, it will melt instantly, and what remains will not be a preserved snowflake. And this is a very common point of confusion. The term resin in science refers to the various solutions that can be used to achieve this. A replica is a copy. A mold creates a negative space. An impression is a surface mark left behind. Preserved snowflakes are none of these. There is no removal step. There is no empty cavity. The original structure remains present. There's no evaporation, just chemically stabilized snowflake. I am always happy to talk about science, history, and known methods. What I do not share publicly is my exact process. That process comes from years of observation, practice, and refinement. So if that is why you are here, I'm sorry. That is not about secrecy. It's about respecting the work that I've done and the skills behind it and being able to later pass that to my daughters. The materials are accessible, the knowledge is public, and the mastery comes from experience. I share lots of information and I certainly hope that it helps. I truly encourage curiosity. Catch snowflakes on dark fabric, photograph them, compare them. Different storms, they can be incredibly diverse and beautiful. Compare different storms. So watch how sensitive crystal growth really is. Even when preservation is not successful, learning is still happening. And I talk about science and art together because that is the nature of my work and because snowflakes live right in between. They are chemistry, they are geometry, they are fleeting moments, and they are also beautiful. A preserved snowflake is simply a moment that was given more time. I share because I do hope to give individuals accurate information. I think wonder and curiosity are important in our world. Snowflakes do not need exaggeration to be extraordinary. They already are. So are you. Thank you for being curious and thank you for being here, and I look forward to next time.